Okay, we're going to use the law of sines to find the area of a triangle, and then further we're going to use it to solve for all the lengths and all the angles in a triangle. So the problem is a sail maker is designing a sail that will have the dimensions shown in the diagram. Based on these dimensions, the sail maker can determine the amount of fabric needed. So first we need to define the area of a triangle. So the area of a triangle, you should remember from about, 5th grade on, is 1/2 base times height. If we are looking at this triangle here, and we see this triangle, A to B to here, we can define H based on A and C. So H equals C times the sine of A. Okay? C times the sine of A. So now we can substitute this into our equation for H, and we get the area equals 1/2 B, which is here, times C times the sine of A. And we can find our area of our triangle. So if we substitute this in, we have 1/2 times 2.13 meters times 2.96 meters times the sine of 73 degrees. And you should be able to just enter that into your calculator. So 1/2 times 2.13 times 2.96 times the sine of 73. You will get 3 meters squared. Now make sure that when you go to mode, your calculator is in degrees. Okay, so your area is 3.0 meters squared. Okay, and this can be used for given any side, angle, side property, you can find the area with that. So if we try it again, in this case, we will have the area equals 1/2 times 12 feet times 8 feet times the sine of 86 degrees. So our area equals, do it again, 1 divided by 2 times 12 times 8 times the sine of 86. 47.9 feet squared. Okay, now when we derived the law of cosines, it was simply saying, using this, that the area of ABC can be defined as BC, 1/2 BC times the sine of A, 1/2 AC times the sine of B, 1/2 AB multiplied by the sine of C. So you set those equal to each other. Then we multiply all 3 of these by 2 to reduce our fractions to 1. So then we get BC times the sine of A equals AC times the sine of B equals AB times the sine of C. Now, what letters are in all 3 of these coefficients to our sine? BC, AC, AB. So ABC is in all 3. So we're going to divide by ABC. And that's to simplify our fraction, our expressions. So then we get B over B reduces to 1, C over C reduces to 1, and we're left with the sine of A over A is equal to A over A, 1, C over C reduces to 1, the sine of B over B, which is equal to A over A reduces to 1 and B over B reduces to 1, so the sine of C over C. Now, when you look at this, the sine of A over A, the sine of B over B, the sine of C over C, all it's saying is that our sides are proportional to the sine of the angle. So the sine of A over A is equal to the proportion of the sine of B over B. And this makes sense. In geometry, the side opposite the largest angle is the longest side, and the side opposite the smallest angle is the smallest side. So this should make sense, and we're just saying that it's true, and it's actually proportional if we use the sine of the angle. So we can then solve our triangles and find all three. If we have angle, side, or in this case below, we have angle, side, angle. So we can use that to solve our triangle. So we have angle, side. And so we're going to use the sine of 40. The sine of 40 degrees divided by 20 is equal to the sine of 49 degrees over r. And we're going to use that to solve for r. So we do our fishtail. 20 times the sine of 49 degrees, 49, is equal to the sine of 40 degrees times r. So then we solve for r. So r equals 20 sine of 49 degrees divided by the sine of 40 degrees. And you can put this in your calculator. 20 times the sine of 49, close your parentheses, divided by the sine of 40, close your parentheses. R is 23.5. Okay, then now we know all three angles in a triangle add to 180, so the angle T is equal to 180, subtract 40 degrees plus 49 degrees. So angle T equals 91 degrees. So then we can use that to find little t. So the sine of 40 degrees over 20 is equal to the sine of 91 degrees over t. So then we've got 91 degrees over the side opposite, the sine of 40 over the side opposite. Fishtail and solve. So t times the sine of 40 degrees equals 20 times the sine of 91 degrees. Divide by the sine of 40. We get t equals, put it in your calculator, 20 times the sine of 91 divided by the sine of 40. T equals 31.1. And there aren't any units, so we don't need to label them. But if there are units, make sure you label. Okay, so the next one you should be able to do on your own. Okay, you solve for angle D by subtracting these two from 180, and you should get E equals 20.5 and F equals 12.8. Now, we have an ambiguous case where you have side-side angle, which if you remember from geometry, you couldn't ever use side-side angle to prove that triangles were congruent. So we're going to be, and the reason why is that you can have a couple of these that are, you can have an angle that have the same side angle, but then it would actually, they wouldn't be congruent because they could be two different triangles. So we're going to figure this out. So in this case, we have A equals 11 centimeters, B equals 17 centimeters, and angle A equals 30 degrees. First, we need to find H, and H is equal to B times the sine of 30 degrees. So H equals 17, I guess B is 17. So 17 times the sine of 30 is 8.5 centimeters. So this is the case where H is 8.5, which is less than A, which is 11. So this is 8.5, is less than 11, is less than 17. So H is less than A, is less than B. Which case is this? That's this case. A is acute, and H is less than A is less than B, which means we have two triangles we can solve. So the first one is where you have A over here, 11, 17 centimeters, 30 degrees. And we're going to solve the triangle. We're going to find B, C, and little c, because this is A, this is B, this is A. Okay, oops. Okay, so we're going to use our law of sines. The sine of 30 degrees is to 11 as the sine of B is to 17. Cross multiply, 11 sine of B equals 17 sine of 30. Divide by 11, and you get the sine of B equals 17 sine 30 divided by 11. So B is the inverse sine because we're looking for the angle of 17 sine of 30 over 11. B equals, you can put that in your calculator. So inverse sine, second sine. 17 times the sine of 30, oops, divided by 11. 50.6 degrees. So then we can use that to find C. So angle C is 180, subtract 50.6, subtract 30. So angle C equals, let's see, 180, subtract 50.6, subtract 30, 99.4 degrees. Then we're going to use our sine again. Sine of 30 over 11 equals sine of 99.4 over C. Cross multiply and divide, you get C equals 11 times the sine of 99.4 divided by the sine of 30. C equals 21.7 centimeters. Okay, then we have to find the other case. So that's one of her triangles. And then the other case is when we have 17 centimeters here at B. A is 30 degrees and little a is 11 centimeters. But this is angle B too. And it's because then we have two angles where the sine is the same. So angle B2 is 180, subtract 50.6. So B2 is 180, subtract 50.6, 129.4. And then you use that to find C. So the measure of angle C is 180, subtract 129.4, subtract 30. So the measure of angle C equals 20.6 degrees. And then you use that to find the length of C for your other triangle. So the sine of 30 degrees over 11 is proportional to the sine of 20.6 degrees over C. Cross multiply, C times the sine of 30 equals 11 sine 20.6. Divide by the sine of 30. Sorry. So let's do it. 11 times the sine of 20.6 divided by the sine of 30. 7.7 centimeters. So those are your two triangles. Now that's it. So then in your homework, let's see. You would do that case down here for number 5. You have 4 different measurements. So let's see, let's do A. So A equals 6 centimeters, and if we look back at our table, A is greater than B, and angle A is acute, so there's only one triangle that we can find. Since A is greater than B, there's one triangle. So we have 4 centimeters, 6 centimeters, 30 degrees. So we're going to use that. So we'll find B and C using the law of sines. So the sine of 30 degrees is to 6 centimeters as the sine of B is to 4 centimeters. Cross multiply and divide. Sine of B times 6 equals 4 times the sine of 30. So to find B, you take the inverse sine of 4 sine of 30 over 6, which B equals, make sure that you close your parentheses. Wait a second. Oh yeah, then you take the inverse sine. Take the inverse sine. 4 times the sine of 30 divided by 6, 19.5 degrees. Oops. Then you use that to find C. You use the measure of angle C. So angle C is 180. Subtract 30, subtract 19.5. C is 130.5. Not to scale. Then you use your sine ratio again. So sine of 30 over 6 equals the sine of 130.5 over C. Cross multiply and divide. C is 6 times the sine of 130.5 divided by the sine of 30. C equals 6 times the sine of 130.5 divided by the sine of 30. Close your parentheses. 9.1 centimeters. Okay,